So inverse, really, 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 really important concept, okay? And that's what we're going to be working on for 2 days. Before we get into what an inverse is, I want to remind you of this other vocab word called relation. A relation is a set of ordered pairs. And a set of ordered pairs can be a whole bunch of different things. Examples of relations are graphs. Think about what a graph is. It's just a bunch of ordered pairs, x's and y's, connected. Okay. Equations that have an x and a y in them, those are just a whole bunch of ordered pairs that you could plug into them and play with. And XY charts, and we'll see all of these, so I'll remind you. So, when you have a bunch of X's and a bunch of Y's, XY chart or table of values, those are all just under the umbrella of relation. So what we're going to be doing is deciding if different types of relations are inverses, okay? Now there's a symbol for inverse. Let's write that first. So like if we have f of x, we put this little exponent of a -1 there, and that just means inverse of f. It could be inverse of g or inverse of h. We can have different letters, f of x, g of x. The inverse is this symbol. Okay, so that's the symbol. And when we find an inverse, it's really, really simple. To find an inverse, you switch x and y, and if necessary, I'm just going to write it though, solve for y. So I'll come back to all of this to explain it better, of course. So with inverse, you want to remember switch x and y, switch x and y. And then the last vocab word I want to review, this is a review, is what is a function? Remember, functions are no repeat x values and they pass the horizontal line test. And again, I know I'm giving you a lot of information here at the beginning, but with our examples, I will explain. I'm sorry, I didn't mean to say horizontal, vertical line test. So a good thing to kind of memorize, because they come up all the time, is there's a few types of relations that are always functions. You might as well just know it, and that's lines and parabolas. So I'm just going to add that here. Always a function. All lines are functions. You know what a line is. And parabolas. And parabolas are like that U. Those are functions. So if you have a line or a parabola, you already know it's a function. But we're going to find their inverse and decide, is the inverse a function? Vertical line test. Yeah, I started to write horizontal and I crossed out. Okay. So I'm going to give us an example, 3 different examples of different types of relations. Let's do a graph first. So just sketch a graph, okay? I'm going to graph a line. So here's a relation right here, and a line. This is an example of a relation. That's just a whole bunch of ordered pairs. And we know this is a function because it's a line. It also passes the vertical line test. But is the inverse of this relation a function? And the answer is yes. The inverse of all lines is still a line. So again, something else to memorize. If you flip all of these x and y's and graph them again, you just have another line, and all lines are functions. So let's not get confused between the three different words. Relation is just a graph, an ordered set of ordered pairs, an equation. A function has no repeats, x values, also passes the vertical line test. And then inverse is, once I do that, is it, or just flipping the x and y. We're still like that. Okay, next one is an equation. Let me just make one up here. That's a relation. It's a bunch of ordered pairs that make the shape of that. The graph of this is a parabola. This is a parabola. But here's the thing. If you do the inverse of a parabola, meaning I take all the points that make it and flip them, you'll get a sideways parabola. The inverse of one of these is going to look like this on a graph. And that does not pass the vertical line test. So is the inverse of this relation a function? The answer is no. The easiest type of relation out of all of them to judge is the table of values. So if I make you a table of values, there's some x values. No matter what the y values are, this is a function because there's none of them repeating. So that's a relation, a bunch of ordered pairs. Is the inverse a relation? Yes or no? Remember what the definition of a relation is? Switch the x and y's. So these we kind of went with like a picture, just kind of knowing some information about lines and parabolas. But look here. With this example, all we have to do is switch these places. In other words, call this x, call this f of x, also known as y. So if I flip those, are there any repeat x values? Do any of these repeat? Yes. So is the inverse a function? The answer is no, because of those negative 4s. Okay. So I know a lot of that vocab is kind of close together. It's a little confusing. But understand this is really, really important, that these are always a function. Lines and their inverses are functions. Parabolas are functions, but their inverses are not. Okay. We have one other type of problem to do, but I see some of you still writing, so I'm going to give you a second. What we're going to do is actually what we did in part B, but instead of doing it verbally, like this is what it is, when you graph it, it looks like this. We're going to actually rearrange the equation. So we're going to move things around in an equation. Switch the x and y and solve for y. There's a relation. If I graphed that, what would it be? What would it be? A line, right? Because it's x to the first, it's linear. We already know that the inverse of it is a function, but this isn't even asking us. All this example is saying is just find the inverse. What would it be? So remember, we're going to switch x and y, solve for y. Remember, we wrote it on the first page. To find the inverse, switch x and y, solve for y. Okay, so you guys probably remember f of x means y, right? It's just a fancy y. So let's start out by switching their places. Switch the two numbers. Okay? Switch x and y. Literally pick them up and take them and switch their places. and then solve for y. When I say solve for y, I mean isolate it. Get all the numbers that are hanging out with him to the other side of the equation. Just like you do with any other. Like if I tell you to put something in slope-intercept form, that's the same idea. What would the first step be to get y by itself? Come on. No, when we subtract 2. But I'm glad you said that, Gabriel, because there's only 2 things we can do. We can either subtract 2 or divide by 3 to get the y by itself. When you're questioning yourself, like, which one do I do first? Think about, like, if I gave you an equation to solve, and Gabriel, look, if I said, what's the first step? You wouldn't have divided by 3, right? So it's the same idea. What do you do first in solving equations? We would subtract 2 from both sides. So I have x minus 2 equals 3y. Now I divide by 3. So my inverse is x minus 2 over 3. Or you could have written it separately, x over 3 minus 2/3. Either one would be fine. Ask the question, guys.